I just want to thank all you guys for coming in and taking the time out of your day and out of the show and whatnot to come learn something. The information that we intend to impart to you is going to be wholly invaluable moving forward, particularly if you ride a Polaris Boost and particularly if you don't have a brand new one. And so one of the top things, I'm just going to go over a couple things that we're going to cover. One of the top things we want to cover is the top 10 items that most commonly are problematic on a Boost. What we can do to prevent them, how we can deal with it, what you should know owning a Boost, and what types of things not only go wrong, but how it manifests, what it looks like in the real world, and what the measures are that can remedy it. So we kind of made that top 10 list, but that's only one of the things. We did talk about, and I meant to bring a sled in here, but honestly, our setup would be pretty long, and I think I can draw it just as good. Anybody who's attended my tech seminars before knows how famous I am for my incredibly accurate drawings, artistic in every regard. All right, no sarcasm there at all. Okay, so one of the things that I led with, we were talking about tracks. So there's a lot of buzz in the industry about the release of the 325. It was kind of a big deal. Everybody that rides in the mountains was aware of the 325. A lot of you in this room probably have some firsthand knowledge or experience with the 325. So we're going to lead off with tracks. Is that good? You good with that?
Perfect.
All right. Chase, I don't know if you guys know Chase, but this is Chase Bunting. He works on our crew. He's an accomplished rider, an industry icon, and my wingman. So we put him on. Of course, I got to test the 325. His machine was equipped with the 275 when we were doing all of our empirical testing, because those were the two tracks that we were trying to compare performance with at the time. And we've got a fair amount of data on that, but we can just tell you what that means and try to cover as much ground as we can in as short a period of time to make this a meaningful input. But if there's anybody in here that has any specific questions regarding these topics as I get there, just raise your hand at any time. I'm happy to stop and address it. I don't want to leave anybody behind, and I want to make sure that I get what matters to you guys out there. You've probably seen a ton of 25 holdovers for sale for $17,000 or whatever. Those are going to be 275 equipped units, and a 325 is a $2,000 track or $1,800 track, so it does matter when you're buying one, and there is an advantage depending on how you ride and where you ride. And so to start with, as we go into this track conversation, it's critically important that you understand that no one answer or no one impression is necessarily exactly accurate for everyone, okay? There's some universal comments that can be made, but specifically, this varies depending on the person, where they ride, how they ride, okay? And not to mention, budget is a big factor in a lot of this, all right? So when I alluded to the fact that the 325 was a significant advantage, it was, and we can say with certainty empirically in Colorado snow, particularly after a couple hundred miles, and every track goes through this process, a couple hundred miles of break-in. And to quantify some of that and make sure that you guys understand the background of it, all of the modern track offerings now are straight 80. Does anybody know what that means? Straight 80. Durometer, correct. Durometer is a reference to rubber hardness, essentially, and memory and some other characteristics. It's deeper than that, but ultimately how hard it is or stiff it is. So straight 80 durometer tracks have been determined to be the industry standard as we move forward. So all of the tracks that we're dealing with, including, but not limited to, the new Camso offering from that bears Brandt's name that we're going to talk extensively about, is a straight 80 durometer track. But what I wanted to get into first was just some basic understandings of how a track functions dynamically and how it interacts with the media, which is constantly changing. And that's one of the reasons why the one track fits all comment isn't necessarily true. It's as different as track lengths. And as there are as many different tracks available, designs and track lug heights and pitches, as there are different motocross tires, for instance. And so it's not unlike that in terms of trying to determine what is the very best one for you. But I just want to cover some of the basics. So I'm going to give you guys some the blessing of seeing some of my amazing drawings. And for those of you who just joined me, welcome. This is Voc Performance. We're doing a tech seminar on primarily the most current modifications that are available out there, as well as some very pointed information regarding Boost specific. So I'm going to draw a couple of things here. I just want to just make sure that you guys understand and follow along. I don't know if you guys can all see this. I wish it was a little higher, but I'll duck down so you can see, and we'll draw a few things. There's some old terminology called approach angle we're going to talk about. That's the front of the slide rail. Okay, so assuming that this, oh Lord, let my marker draw a little better than that. So oftentimes when someone refers to, this is the driver right here for those of you who don't know. Okay, we're just going to, assume that's the driver. And then the belly pan interaction generally takes place somewhere on the lower one half here. So sometimes up higher or lower. So as the sled travels through snow level, the snow transfers from the belly pan area into what's called the approach angle. And as we've learned over the years, this approach angle is a big contributor to the sled's tendency to float. But that's what I wanted to get into, is why. So let's just assume that there were paddles coming down, okay? And these paddles come down. Let's just imagine that these paddles were solid, okay? Meaning there was no give at all. They were a billion durometer for the sake of understanding. There are two things that this does. You can see that the interaction with the media, which is going to be, let's just say, fluffy along this plane, and the angle at which these begin to interact with that, and why this would not necessarily create lift, but would rather create forward propulsion or rearward discharge. So those are two things that happen during interaction of a track with snow. You have rearward discharge, right? That's the capacity to just bushel the snow out the back of the unit. That takes place during the time that the track speed exceeds the vehicle speed, which in deep snow it pretty much is all the time, right? So minimizing the amount of discharge and increasing the amount of traction or forward motion is a function of a cool effect that takes place on these paddles when they begin to lean back. This is achieved through the variance of durometers and track design. As these paddles lean back, as they begin to interact with the snow is forced downward, okay? This is called the pack face. This pack face is most crucial on the area of the track called the approach angle. And everybody can see why, right? If this isn't graphic enough or you're having a hard time, raise your hand and Chase will call and tell me to stop. But I'm just making sure that we're understanding. So as we create a pack face, then the sled travels forward over the packed media, right? And then these stiffer paddles that no longer bend over because because there's so much paddle involvement, say from this margin, that all of these paddles are no longer going to be bending over as much, right? The bend would be less and less and less as it goes back. In other words, there'd be a gradual bend, the other way, because I suck at drawing. There'd be a gradual bend and it would become slower to where the rear is back here and that paddle begins to travel around the rear idler wheel, right? Okay, so this, in a perfect world, is packing. Now, as we have introduced boost and high horsepower, the attitude of these units changes, right? Because the things are in a wheelie a lot of the time. And you can see why that matters also with respect to how the sled goes forward. And that's an important thing to keep in mind, but the principles are all the same with regard to the functionality of the interaction of the paddle with the media. Okay, so we're going to cover just a few basic things. I don't want to spin out here, but can anyone imagine? So if we don't understand how a track is measured or the terminology, each bar that goes across a track is referred to, this margin, and each bar is referred to as a pitch. Okay, so with each pitch of the track, so when you hear somebody say, oh, that's a 3.0 pitch, that's a 3.5 pitch, that's a 2.75 pitch, that is the reference in inches to this margin right here between the bars. Follow me? Okay, so you can imagine that a large pitch track versus a small pitch track would have more paddles per foot of track, or at least more available rods in which to fasten paddles to, because the paddles are always on a cross rod. Okay, so this is pitch. We understand that. This would be a large pitch, short pitch. When we're talking about short pitch tracks, which is where you've seen a trend in the industry to move away from shorter pitch tracks, and part of the reason is because the paddles have gotten higher, taller, right? So another thought experiment back down here to this, imagine that if we had these, proportionately, these paddles were super tall like that, but we had a very close pitch. As this track spins, we start to lack the capacity to interact with the media because we don't get what's called paddle fill. Okay? Why? Because this portion of the paddle is now interacting with the snow, but nothing up here is, right? It can't travel up into that gap. It's a short pitch track with a super high paddle. So for that reason, we have stretched these out. We have eliminated that. We've made these pitches 3.5 inches rather than, say, 2.58, which was the industry standard 10 years ago. So from 2.58 to 3.5 is a pretty significant difference in pitch. That's because we've made a significant difference in paddle height. And the effort to fill the paddle to cause this entire face to be involved in propelling the machine by having snow fill each one of these gaps like that, right? So this is the drive face of the paddle. It acts as a pack face during the approach angle, whether you're in a wheelie or not. Whatever surface first touches the snow is referenced as a pack face. Forcing the snow down gives you the capacity to pack it and then ultimately drive off of it. You can imagine with a very stiff track that it doesn't pack again, but rather bushels it out. That's the reason why you'll see a very stiff track has a tendency to what we call trench in our industry, or just not affect forward motion. So does a 12 o'clock wheelie, Billy. You don't go fast up the hill in a 12 o'clock wheelie. You have to lay the front end down.
Why didn't you ever tell me that, Billy?
Yeah. Okay, so I just wanted to get everybody in here on the same page with understanding the basic dynamics of how a track and snow get along effectively, right? So now we can get into kind of the theories behind different designs of paddles and what's going on, say, with the new Brandt track, because that's a worthy conversation to have. And there's been a ton of industry innovation in tracks over the past 10 years, including like the Arctic Cat Power Claw, which had a marriage of some very firm outer pillar-shaped components, as well as some more limber inner paddles to affect that pack face and ultimately grab, right? And that's how it ended up being called the Power Claw. So that's worth noting. Previous to that, we had entries like does anybody remember the Attack 20? So the Attack 20 had a 20-degree negative angle, right? When it was installed as intended from the factory, it was a negative angle track. And you could see how that was a benefit in chicken feathers, right? The faster you spun that track, the more lift you got, and the better you could stay on top. Like almost mystical lift in some conditions. But you might also remember the Attack 20 was miserable in virtually every other condition. It was awful on the trail. It was terrible in the groove. It wasn't a wildly fast track. It was super noisy with the wide paddles, a whole lot of trouble, right? So what's happened recently is manufacturers have tried to find a way to broaden the spectrum of usefulness in terms of different media conditions, use demands, etc., to a broader spectrum of riders to be better more of the time. Does that make sense? Okay, so the creation of the Brandt track, in fact, I'm going to delete this here now that we understand how that works. And we're just going to draw a track here. We're going to draw a paddle design, and we're going to compare these two different track designs. So what you're going to see here, this is going to be terrible again. I'm going to draw some windows. This is awful. And I'm not going to draw them all because that would be really, really tedious. These are meant to be rectangles. And then over here we're going to have, whoa, no extra charge for that. 325, the 325 has 3 windows. And the 310 has 2 windows. All the way down. Okay, now, there's some intentionality here that I wanted everybody to take note of. And so I've had some extensive conversations with the engineers involved in the creation of this track that is now labeled as the Brant track, and why and how these decisions were made, and what the advantages and disadvantages are. So the 325, one of the first things that you should notice that nobody noticed and nobody talks about is the fact that the windows on the new 3.1 are much narrower, and there are no center windows. Polaris used to employ a center window because they drove with the center driver. It was an extrovert, and the others were an introvert, meaning that they didn't poke outward, but rather drove on involute rubber nubbins on the inside of the track. Now, everything is being driven with twin extroverts, and that center is no longer employed, but they still have this center window. There was mixed data regarding advantages and disadvantages. I'm going to back everybody into the time when we used to take a hole saw to our tracks. Does anybody remember that? Do you remember the tests that we found? You were involved in some of that, actually. Do you remember what we found? We found that the track got notably lighter. We also found that we had, what would you call that? Pitch deformation, from an engineering term. Pitch deformation. We started to stretch things out that we didn't mean to stretch out because the tracks got notably weaker in between the pitches, but that's not why. We thought it would carry less snow, right? It was like, oh, it's going to carry less snow. What we actually did was we made stiffer tracks softer by doing that, because the paddle was able to bend more than it was intended to bend because there was no strength in between the pitches. But moreover, it actually, in most conditions, carried more snow in the skid frame than less. They tended to trench more and not float. So we learned all that the hard way by drilling holes in $1,000 tracks all the time, thinking we were really cool, and we wrecked a whole lot of tracks. So this was formed. Yes, it will carry more snow into the high facts and cool better. Yes, it will cool the snowmobile better, which is the reason why Polaris still thinks that's important to have that, because it does pick more snow up and push it up. I shouldn't have cut the drawing out quite yet. As these stiffer paddles go around the rear idler, that's something to remember. The longer and stiffer the paddle is, the more parasitic draw there is on the rest of the system, because of the effort it takes for that paddle to flip out of the snow and come off. So that's important. But that action also has the benefit of creating better cooling in the tunnel, because we do have, modern snowmobiles have very limited coolers in them now, comparatively, right? We used to have coolers that went the whole length, and 99% of the time we didn't need them. We were just carrying around 20 pounds of extra garbage. But there are times you wish you had it now. So the cooling does matter, and this isn't irrelevant. So I'm not bashing the manufacturer for doing this. It's probably a good cover to, again, make an effective track that can fit more people's use and more people's use demand. Okay, but as we moved forward, the development of this track was very pointed to be the best Colorado track, to be the best in the deep snow, when you have either an unpackable, unpacking, or bottomless media, something that relies on both track speed and lift in order to propel the vehicle, rather than traction from the standpoint of clear, solid interaction with that. So hopefully I'm being clear. Is everybody coming along on this journey? Is this making sense? Okay, so when this was developed, it was developed to be the best at that. So by limiting the windows to the exact width of the high facts, it doesn't allow any bypass, and that makes it inherently float better and carry less snow. So it's effectively lighter. Yes, there's a cooling compromise. Okay. Now, the next thing that you're going to note on these tracks, these tracks on the series track, like the 325, have a series of short paddles across. This is really bad, but you're getting the point, right? Okay, so there are 4 rows of short paddles throughout the whole track. That's how this works. Every track pitch is in every other pitch paddle present. So every other pitch of the track following its former one is another. In other words, there's a bar here, 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 and here. But when you look at any one profile or run of them, you'll see that there's just a paddle on every other pitch. That's the series tracks from Polaris. That includes the 2.6, 2.75, 3.0, and 3.25. So this has advantages in that it is efficient at high speed because air is allowed to escape. Everybody that has a Polaris that has tried to put bigger and bigger and bigger tracks on them knows that the problem with that is that there's not enough tunnel clearance to clear them, so the compromise is we keep having to go to smaller and smaller and smaller drivers. And the smaller drivers suck. Why? Can anybody guess why smaller drivers suck? Do you know what the driver is? Yeah, kind of. It's actually less efficient the tighter you bend it. Yep. The tighter you bend the track, the less efficient that whole assembly is, right? If it rotated as a giant wheel, it would be the most efficient it could be. As you pinch that down more and more and more, you ultimately compromise efficiency. You impart heat, which is mechanical energy, into that track by bending it. So that's the reason why guys will put like 10-inch rear idlers on and, you know, giant drivers, because they're freer. I mean, you can literally like let it off the ramp on your snowmobile trailer and it'll coast down it when you get it real good, right?
As long as you do it the correct way.
The correct way.
The correct way. Do not have your wheels sticking below your rails. You go the other way.
Right, right. So anyway, I just want to say that is in my opinion, a disparity in design on Polaris's part to not have more room in the tunnel for that. But the series track does deal with air pressure. The fact that you have to make a smaller driver is because the track is much closer to the bottom of the tunnel at the front of the tunnel, right? So the apex of that corner, there's not much clearance there. And the more air you try to cram in there also affects efficiency, right? So the thing won't turn as easily because you're packing a ton of air into it. That's a big player when we talk about this other track, a big player. So this is really important to know. So air pressure matters. This gets rid of air. It also, though, you can see compared to the 310, and this is going to be difficult to draw, but I'm going to do my best. We have in every other pitch, this is somewhat exaggerated, I apologize, but we have these great big long paddles. So what comes along with the long center paddle on the 310 Brant track, which is also the paddle that is 310, is the center. They're the only one. So if you were to draw a profile picture of it, it would look like this. Probably nobody can see that because it's too small. Does everybody see that and do they get it? These side paddles are only 2.9, actually 2.906 or something like that. And these are actually slightly over 3.1. But the center paddle's 3.1, okay? So this is really important to note. The center paddle's 3.1 and it's very wide. You notice something else in this picture and in this? There's overlap. There's not overlap on any other track right now. So a pitch-to-pitch overlap is different. It's not a common design, okay? That's being done. These outer paddles are biased to force snow to the center of the track. They're shorter so as to make it more reactive, not unlike a convex track did on, say, earlier timber sled, which was a similar design, actually. On earlier timber sled, when they were trying to create vehicles that floated with lower track speeds, but ultimately were better at it, that was one of the things that came away from that. So force the snow to the center, have a larger paddle pick it up in the center, and you'll create a flotation in the center that allows you to roll over that hump, if you will, with less rider input. So when Chris says, and Chris is amazing at comprehending and articulating how it relates to the rider, but not necessarily the engineering aspect as to the why. I'm a why guy. I want to know why you felt like that sled was easier to ride. But here's why. And I like to try to explain it in terms that you all can understand and take away as to why this track, in a lot of conditions, will feel easier to ride. It will react to what we call peg weighting, right? We ride more neutral now, so when we push on one running board or the other, we expect the sled to react, right? as we're forcing the snow to the center, we're creating a bit of a pack that is in a dome shape in the center caused by that function, right? And then our bigger paddles are keeping us up on top of it. But not exclusively, because if we bent them all back for flotation, we wouldn't have the bite that we really want, particularly because the side paddles are shorter, which would really suck, right? So the 3-1 addresses that in a very unique way that I have seen no comments on this, not from Chris or any of the engineers or camps or anybody, but one of the first things I picked up on and asked the question the engineers about was the structural differences between these. They're all 80 durometer, but 2 paddles in a row are just a paddle, thin rubber paddle. Then every third paddle has these giant gussets on both the front and the back of the paddle, all the way. So you can note that when you look at these now out in the deal, has big gussets. Those gussets actually serve a pretty important function, and I was surprised. I was surprised to see that, but after thinking about that, it became clear why they had to do that. Otherwise, you would attack 20 all the time. You would spin out. The tips of that 80 thin that are acting as pack faces on your main are ultimately not going to be able to grab anything unless they have some structure. So that's what's going on. So this is a very asymmetrical track, and it deviates from conventional wisdom with respect to track design pretty radically, even though it looks like a hunk of rubber and everybody's like, yeah, cool. Don't buy something just because somebody says it's good. Buy something because you understand how and why it relates to you and why it's worth the money to buy. If this all makes sense to you and you think this is something worth doing, then you should know this. These are all, on the 325, are all a symmetrical paddle, meaning they're all identical, and they're all doing the same thing. And this is a really good track for busheling snow. But one of the things you'll notice, and anybody that's ridden a 325 extensively in deep snow can appreciate the fact that it does tend to go straight in the direction that you're pointing it. When you pin it, you're going that direction. It's not as easy to knock offline, if you will, as the 275, which was had a little bit more give. And that is a function of all of that paddle interaction, good paddle fill, and straight traction with a big, high symmetrical paddle all the way across this way. So when you look down that, you'll see it is just a solid, I'm sorry for the dip, I can't draw straight lines. Anyway, you get what I mean. So we have a bunch of little paddles breaking this up, right? But when you look down it, that's what you see. And that's not as easy to do this on as something like this is, where it's feeding the center, biasing it. It's shorter to begin with, allowing that to be a little bit easier to knock offline or to be able to affect with less peg weighting and interaction from the rider. So that's the main things I wanted to talk about. We pack, and grab, okay? We feed it to the center, and we lift off of it. That's what that track does. And so that's short of getting into too much of the engineering. I just wanted to get there, take you down this road so that you understood how they work, why they work. And now for the detriments to this track, because this all sounds really cool and you want to run out and buy one, this track is noisy. It packs air really hard. It doesn't have the top speeds or efficiencies, and it doesn't cool quite as well on the trail. Got it? So know those facts when you go make these buying decisions. A universally great track is this one. It does everything really well. This one's a more specialized track, offers some advantages, but you got to know what you're getting when you get it. With respect to durability, I can't speak to that.
What about weight?
What's that?
What about weight?
1 pound lighter in a 55. So the brand track's slightly lighter than the standard 325, slightly shorter too. Here's an interesting little ditty though. When you look across this, even with the gaps from Hyfax, the 325 and the 31 have exactly the same square centimeters of paddle face per pitch. Identical. So that's interesting. One's a 325 and one's a combination of a 2.9 to a 3.1, right? You would think that would be a compromise, but it's not because of the paddle overlap. That's where it makes up for it, which keeps it from leaking out the side of the paddle, right? So effectively leaking that pack that we pushed in. So that's what that does. But they are the exact same. So don't think for a minute that the 325 offers an advantage in terms of actual face hitting the snow. It doesn't. It's the exact same, so remember that. But I just wanted to put a big black check through this thing because I got hit on like every Facebook and email and everything for 2 weeks was about the new Brant track, and I wanted to make sure everybody got it. So is there any other questions on that before we move on to something? No more awful track drawings. Now I'm going to draw some awful clutch drawings because we gotta talk about that real quick. This is just going to be a real quick. We have a term at the shop, the real quick. Our manager real quicks us.
Yeah, my
all the
favorite.
time. Yeah, Chase can tell you lots of real quick stories. It's when one of you guys walks in and says, "Hey man, can you throw that Skins hood on real quick? Can you put a set of A-arms on real quick?"
All I want is a tune on my snowmobile.
Just
and
give
then
me a
it's an
quick tune
exhaust
and a
an
clutch
intercooler.
job real quick. So this is a real quick. All right. So there's been this recent move, and you'll see on some of these mod sleds around here, to put the P85 on your boost.
Ooh, yeah, here we go.
Super cool. The P85, everybody knows, is the most venerable clutch ever built. Right? Dang it, I forgot my prizes. I got prizes for you guys. If you come to my booth after this, whoever answers these questions, I'm gonna need you to keep track of this. Somebody keep track of this for me. All right. Excluding staff, don't answer these. You're not, Can anybody tell me why the P85 is called the P85? Whoa, who raised their hand first? We'll split it, you both get one.
1985.
As what?
Built, designed.
That, yes, first came into production in 1985. Most of you guys have like kids younger than that. Okay.
I was 5. It's older than
Most of that clutch is older than most of you. So the first thing we're going to do is talk about, yes, the P85 was a superior design in its day. It's a good clutch. By today's standards, with respect to durability, it's not even, shouldn't even be considered a viable solution on modern. Yes, it's undergone revisions. Materials have changed. Things have gotten better. It still has the same dinky little rollers, the same dinky little cam arm bushings, the same crappy little slit in a spider that doesn't allow you to run enough weight, a kind of a compromise in the spring pocket, and a wealth of other inherent design flaws. The reason why they designed the new clutch was to get away from these things. So if you love changing your cam arm bushings every 300 to 400 miles, buy a P85. If you loved wrecking roller bushings on your spider, buy a P85.
Ooh, my favorite, belts.
If you love blowing belts,
Tension.
buy a P85 because they were terrible at heat. If you love setting your belt deflection every day, buy a P85. We have yet to quantify a performance benefit empirically to it. By the way, this one right here is running a P22. And we can all watch that in Kosterski's new film, Progression, ripping up chutes at 80 miles an hour and developing 82 miles an hour worth of track speed in 7 seconds. That's done with a P22. One of the reasons why people were compelled to put P85s on were because they had a better wealth of knowledge and a better supply of calibration equipment capable of creating the squeeze necessary to propel their machine to their standard. But sheave angles are exactly the same. There's not a wild difference. It's just what's available for calibration, understanding how to tune the P22. It is a new era. So obviously you can tell my biases. I speak strongly against it. I think it's a step backwards. You literally are shooting yourself in the foot. Can the P22 be problematic? Yes, and what we do to fix it. And that leads into what we were going to talk about in the next 10 most common items that we see problems with. We're going to turn the page on that a little bit, though this is still an open discussion to be talked about at any time, for any reason. But the P22 from 22, 23, 24, 25, so when we've seen it, now in 26, has underwent a significant number of changes, and those changes revolved around the failures that we saw in the field, and what caused those failures were important and worth noting. Okay, so we're going to talk about P22 a little bit. If anybody knows how the P22 was built, more awful drawings, by the way. The P22 is built like this with a portion right here that is splined. The spider comes out like that, has a roller, is splined onto this section of the shaft. It's important to note that the spider went on this, okay? The stationary or the movable went, goes like that and goes over the top of it, so you don't really see that all that much. But anyway, this is piss poor drawings, but I think I get the point across. And then there was a shaft assembly that stuck in here. It was separate from, there's a flange, and then how to best describe that. It's a terrible picture, but that, if anybody knows, the retention bolt, you know, which goes in here, it went down in there and held that whole assembly together. So what we had happen, or what you most commonly see on the internet with respect to failure, was these assemblies were coming apart, right? Players built junk and they come apart and they're no good and throw them away, put a P85 on because they didn't do that. Never mind the 75 things the P85 did wrong, put it on.
We'll talk about the castle nut that holds the clutch together, and that'll be the, you know.
Yeah, right.
That's the good thing.
Right, because there was a castle nut right here on a P85 that held the spider to the shaft, right? So the bolt was charged with one job, and one job only. And believe me, P85 bolts failed too. All I had to do is hold the clutch on the taper. You win. Okay, he's a winner too. All right, so its one job was to hold the clutch to the taper, the clutch assembly. The P22, the bolt shared the job of both holding the spider on as well as holding the assembly onto the taper. My opinion was that was suboptimal. I get it, they were trying to make a clutch that was more serviceable, but things changed over time. So what actually led to this bolt's failure to do that in most cases was this bolt came loose. So the bolt was junk, let's put a bolt in it. That's the dumbest assumption. This bolt came loose because why? So I don't even want to hear everybody's Facebook comments as to why. I'm going to tell you the truth as to why. The first rendition of it came loose because the interaction between the spider and splines allowed the spider to move slightly, and that was the device that the bolt had interacted with indirectly on this collar, which then worked to move the bolt looser and looser. As the splines got looser and looser, the bolt wouldn't stay tight because the spider assembly would work independent from the shaft and ultimately independent from the crank, which is where the threads are, and it would work the bolt loose. So if you retorque your bolt every ride, I heard people say that, retorque your bolt every ride and you won't have the problem. That's not entirely true. Truth is, it was a design flaw. That shouldn't have been that loose. So they addressed that with a new material spider. You remember they came out with a new billet material, as I believe was 7000 series 775 billet spider that was much tighter tolerances to the splines, and that all but alleviated the problem completely. It really did a great job of it. Then they did actually have a run of bad bolts, so there was a need because of manufacturers not reaching their specification levels, both in tensile as well as there was some flaws internally in the material. So they had to issue a bolt recall, but it wasn't all related to the bolt. The problem really was the interaction of the splines, which then again were updated with a newer, even harder material for the next year, which would have been last year, and an even tighter tolerance to the splines. So anybody that slides a 25 spider off knows what a bitch they are to get off, right? You're banging the thing off.
That's a brand new.
It's a lot harder, but that's a good thing, because if it wasn't, it would move like this and loosen your bolt.
There's a really important thing to note with this too. This particular design and what he just explained and why that clutch comes loose, what also happened during this time with snowmobiles and motors.
Yep, it is very
The
important.
year is starting to get into higher horsepower, bigger board motors, and more power, more quick revving.
Lighter
so what's
cranks.
that, and lighter. So
Right.
anyone that's ridden a 9R, what's the one thing you like to do across the meadow on that thing? You're just running your thumb like a madman. Every single power input that you give that snowmobile is going to whack that clutch.
So every combustion event.
Yeah.
So what we saw was mid and low level 9R failures on this, that failure I just described were massive, but high altitude and boost failures were tiny. I know guys that have 3,000 and 4,000 miles on 22 boosts that have never even touched their bolt. Never broke it, never spun it open, never touched their bolt, didn't make any difference. The difference.
What Patrick came out with, right?
Well, no. So we're going to back into that. Kurt from Carbon Sled patented that and developed that, this part right here. And it's a good part. It's a good part. And he offers it in titanium and in carbon steel. So So just so you know, but we'll talk about what that part does. But to Chase's point, it was really important why we saw low and mid-altitude 9R equipment failing when we didn't see high-altitude 9R equipment failing, told a little bit of a story. The violence of each combustion event is on a crankshaft is an immediate bang on that crank every 180 degrees of revolution per cylinder. So, right, so or per each cylinder every 180 degrees, right? So it goes bang, bang. So it's like taking a sledgehammer to that spider, because that's the part that's driving or being pressured, right? The belt is being held by that. It's trying to propel the machine, so it's constant. So imagine the reverse of that. The 9R is an effective impact wrench, right? We all know what an impact wrench is when we're trying to break something loose. That's what it's doing. It's breaking it loose, rattling it back and forth. The 9R's crank is way lighter than Boost, so that's the main reason we saw way more 9R than Boost. Right? It's way lighter, so each effective combustion event was a better and more effective impact hammer on that spline. That's what loosened the spline. So they failed to see how bad that was going to be, and the material changes and whatnot led to these failures, and ultimately that's what happened. So don't think if your bolt comes loose that you just tighten the bolt back up and go riding, because the thing's going to come apart, and it's going to come apart hard. Get that assembly replaced. Polaris, I've not known Polaris to deny one warranty claim.
Yeah, they haven't. If it had that problem, you get a new clutch.
You're getting
whether
a new
it's in
clutch and a
warranty or
new
not.
bolt, and then the process of putting the bolt on. There is one secondary thing that can lead to that bolt coming loose and the assembly failing, and that's failure to abide by the manufacturer's recommended method of fastening that to the crankshaft. There's a process. And there's another step you can add to it to even make it better. But the process is you use what's called a draw bolt. Does anybody in here know the draw bolt torque on a Polaris P22? 140. Ding, ding, ding. That guy's a winner. Now, if you were to install a fastener, a hold bolt at 140, it would break in the tensile as soon as it got hot, because it can't expand at that rate. So it's going to fail in the tensile. So the reason why the engineers determined that it's best to use a draw bolt, and you can use an old bolt as a draw bolt too, but just make sure to grease the surface that interacts with the face that it's touching. It's very important, the threads and the face, so you don't get any galling and you don't get inaccurate torque, okay? Torque that baby on with 140 foot-pounds, take that bolt off and throw it in your toolbox, put the new bolt into 110 foot-pounds. That's the process. But one of the things that people overlook is the cleanliness. I see this all the time. The working in the how many times have we seen this? Guys are working in the parking lot and they throw their clutch down in the snow because they just popped it off by hand or whatever, and then they just stick it back on. And there's water and grease and grime and the oil that they smeared all over the clutch taper. It isn't a problem with oil being the lubricant, it's a problem with it stopping the taper from fully interacting with both internal and external bore, right? So that thing has to fully seat. Otherwise, it will trap that, you'll torque it, and then over time that will leak out and it will lose tension. So clean the crank taper with isopropyl alcohol and the inside of the drive clutch with isopropyl alcohol. Make sure it is clean before you put it on.
Because that is a bad one when it fails. When that clutch spins off, your crank gets ruined.
Right.
And then your whole motor's ruined.
And what's the term to describe what happens when it spins?
Galling.
It micro welds.
Micro welds,
remember?
yeah,
Yep.
sorry.
It will literally micro weld the crankshaft to the clutch bore. That's the guys that you see with the 20-pound sledgehammers on the internet saying how to take your clutch off. You just hit that son of a whack. Yeah. It should never come off that hard. If it does, you micro welded the crankshaft and clutch together. Don't do that. Don't be an idiot. So it's important. Dealers are as guilty about this, and I say that to everyone. Dealers are guilty of this too. Without properly trained technicians, the incompetency level in the dealer network, unfortunately, is higher than any of us would even care to admit. I am a stickler
Especially on
about
something
this.
like that where you're saving time.
Saving time, because it's all flat rate. It's on there,
Don't
drives,
save
it's
time.
fine. That problem won't manifest for a year, but it does. Okay, so we go an extra step at Voke and Alpine Motorsports where we use a lapping compound to lap the clutch onto the crankshaft. That's done just like valve lapping or anything else. So it's a diminishing aggregate abrasive compound that you put between the clutch taper and the crankshaft, and you work it back and forth until it diminishes and becomes smooth, and work it, quarter turn and work it again, and a quarter turn and work it again. And what that does is essentially forms any micro imperfections to the both mating surfaces being identical. And then we remove that, clean all with isopropanol, use a draw bolt and torque it, and never, ever do we have a problem removing a clutch, micro welding a clutch, or a bolt coming loose. Not one in any of our units. So that's very important. Anyway, back to this. This part that was designed by Kurt at Carbon Tech was a really cool fix. The internal component inside these splines is built to accommodate the puller, so that you take your bolt out, you drop the puller in, it goes to the internal threads, pushes on the crankshaft taper, and pops the clutch off. Everybody knows how to take a clutch off, or if you don't, that's how it works. Okay, so those threads are pretty robust. Kurt determined that if you built this collar, this sleeve that they call it, that just pops into that the bolt holds it on, if you built it with threads and ran them into that puller thread, then you could use that as the component to hold the clutch together, and you would effectively have an updated P85. Now the bolt, this one, its only job is to hold it to the crankshaft. So we've taken away the need for it to hold the spider taut. So in other words, this now serves as what used to be the castle nut on a P85. Does that all make sense? Are we all clear on that? That's all that happened in the industry. Everybody else is just fluffing it up. So that's the truth behind the P22 and that. So is there any?
If they didn't get it before, there's literally no difference in sheave angle between the P.
The next and most important thing was regarding the information that's out there about, I'm going to draw this as the center shaft of the clutch. Okay, and I'm going to draw a small ring around this center shaft of the clutch. It's not going to be very round, to represent the bearing that's on a P22. And then just for illustration's sake, I'm going to draw something back here that represents the outer diameter of a driven. Okay? So the information has been put out there in the industry that the P85 has an advantage, and that same advantage can be found on the P22 by removing and discarding the bearing from the center shaft. So this bearing can be discarded, and then you can put a belt deflection adjuster back in your secondary so that you get to adjust your belt all the time again. And then you gain the advantage mechanically, and this is exaggerated, by the way, and I'm going to give you some statistics that are surprising. If you wrap the belt around the smaller portion here, you can imagine that you would have a larger mechanical advantage wrapping it here. If anybody's ever ridden a 10-speed and looked at their chain, versus coming around the bigger bearing section, right? So very obviously, as Chris put it, you're starting out in 1.5 gear rather than in 1 gear. So if you throw the bearing away, you get to start out in first gear, you get a gearing advantage. Conceptually true. It's grossly exaggerated, and here's why. The belt that wraps around this bearing is fiddle string tight. You ever felt it? They're tight. You can't make them any tighter. They're as tight as they can be. Okay. The belt that wraps around this shaft has, what do we know? It's got to have at least 1 3/4 inches of belt deflection, right? 1 3/4 inches of belt deflection ends up being almost 200 thousandths. That puts you about 3/4 of the way up that bearing before it's tight as the one that was on the bearing. The difference in lockup speed is 2.6 miles per hour. That is a very minute difference in lockup, and a very minute, almost imperceivable difference in mechanical advantage at low speed. If you did throw away the bearing or put a P85 on and run your belt fiddle string tight, the machine won't start, or it will drive across the parking lot if it did before you could catch it. We have to have that belt deflection. If you run your belt deflection perfect, you might, if you're a really in tune guy, be able to say, yeah, I can tell a little bit difference. It does feel a little better. But it would only be on drive off, because the sled only spends that first 3/4 of a second on drive off from a dead stop anywhere near this section of the drive clutch. That belt moves up this drive clutch within 3/4 of a second. And I don't know about you guys, but I'm not building sleds to perform just in the 3/4 of a second if I could perceive a 2.6 mile per hour lockup advantage. So again, just saying the facts. Yes, it's true, it's not patently false. Is it a real advantage? No, I don't think it is. And I think it's a bigger detriment because 90% of you guys don't adjust your belt deflection if you had to. Do not send your P22 in, have that bearing removed and the removal kit put on, and put it back on your sled, and then just put your adjuster bolt in here. Does anybody want to tell me why? There's like a free koozie at stake here, I don't know. Because the damn thing's not balanced with it, is it? That's secondary. If you do that, has to be balanced with that big 1/4-inch bolt adjuster and nut in it. That thing spins 8,000 RPMs, and that bolt will, if you look at the spin sheets, will produce about 60 pounds of pressure at that. It's a lot. It matters. So don't do that. Also, if you did receive a boost and it has a bolt in it, don't take it out and throw it away because the clutch was balanced with the bolt in it. So it's important to know. If you haven't considered the theme yet, my theme, the premise of Voke Performance has been to stop you all from pissing money away on things that either don't work, don't make a difference, or don't benefit you directly. Don't do it. I'm not telling you don't do it, don't do it. I'm saying don't do it without all the information. There's more facts out there. So as an engineer in this industry for 35 years, I want, most importantly, to impart information to you guys that's useful and you can make good decisions moving forward and spend your money where it matters, right?
We'll always shoot you straight. We'll tell you the best way to spend your money.
Help you and not require you do it through me. That's not the point. I truly, truly, from my heart, just don't want people to invest in things that don't work, okay? Or things that don't matter or don't work for you specifically. All right, so that brings me to one more of the 10 things. So this is going to be on my 10 thing list. We're going to talk about Polaris Boost's bog in deep snow. That's true. If you buy a stock Polaris Boost and run it in deep snow, it's going to bog in deep snow. And it will bog more than your buddy who bought a Skidoo. It's not impervious to it, but it doesn't bog near as much. The Polaris bogs in deep snow. And it bogs for a myriad of different reasons. And almost all of the reasons that you'll read on the internet are incorrect. And almost everyone trying to sell you something to cure your Polaris bog is lying or just ignorant to what is actually causing the bog, okay? One of the first items that came out in 22 when the boost dropped and everybody was bogging in deep snow is an anti-deflection device or a silicon rubber inlet for your turbo. Ditch that flimsy rubber thing at the inlet to your turbo because when they
closed and
when the intake gets plugged up, that thing draws into negative pressure and that boot just closes itself. So we thought, man, I wonder if that's true. So in typical Voke fashion, we actually empirically tested that.
Yeah, we didn't just shove a GoPro in there.
Yeah, we didn't just shove a GoPro in there. We learned that in order to effectively distort or deform the rubber boot at the inlet of the turbo, you had to draw that to 1.8 pounds of negative pressure. Actually 2 to even begin to close it, but you could deform it at 1.8 psi of negative pressure present. The engine fell on its face and puked at 0.4.
Yeah. You're in the ditch, not running at 0.4 of a PSI.
So if you create negative 0.4, negative 0.3 is a perceivable difference in runnability, negative 0.4 PSI every time you are bogging. Done. So yes, does intake starvation cause bogging? 1,000% empirically proven over hundreds of thousands of hours of data logging. I can prove it every time. I can show you that it happens. Okay, so was it the boot though? 1,000,000% no, don't piss your money away on a silicon rubber boot or a little metal bracket that you put over the factory one.
That goes inside.
Yeah, so that it won't deform. That is complete horse crap. Now, there were some companies that built some very high quality silicon rubber boots that look really nice and they are good. But there's reasons why you don't just put silicon onto the turbo. If you look at the factory boot, you'll notice that it was formed with an inner radius lip that exactly matched the inlet of the compressor housing. And when you just put a hose on it, there's a big lip And that little bit of turbulence creates a problem. And it is a noticeable disparity in what we call drive-off or pickup. So you'll notice that if you're sensitive. And that's a problem. So don't piss money away on a silicon rubber tube. But if you do want to buy one, a company over here, Bikeman, they built one that they actually spent the time to match that inner loop to. So, or lip to. It's a pretty good part, but you don't need it. So there's that. All right, so that was one of them. There's a ton of intake-related solutions out there. You've probably been by my booth and saw a couple of hoods with intakes on them, the Guzzler, the Speedworks hood, a giant intake built into the hood itself. Those intakes are cool solutions. They will definitely allow you to breathe better. But in most of the case, well, like for instance, the Speedworks being a flat surface, snow will get on that, and in the right conditions it will freeze and it will create an intake disparity, and you won't completely eliminate the problem. However, if you were to incorporate your umbrella valve from the stock or the small bypass valve that's in your stock, it might be a benefit. So if you run the Speedworks hood, which I think is a good product, it's super light, you would want to do that. And also, there is an update to that hood design that's going to have sort of a pyramidal design to that flat surface that will allow it to shed snow and have a little bit more durable frog skin because people were concerned about that. All those are viable solutions and they do solve problems. Boondocker has a Breathe Right system that incorporates 3. That's what we were showing on our sleds. Those 3 also solve the problem. Anyway, yes, you do have to deal with it. If you want to run appropriately or properly in deep snow, you will have to deal with the intake, whether it's a Breathe Right, Ibex, the Speedworks hood, Guzzler hood. All of these are viable solutions, but at the end of the day, you're just trying to get it more air when it's deep. But that is not the only reason why they bog. It's still a prevalent issue, is exhaust cap off. And the combination of the two do matter. So if you want something that literally runs as a submarine in no matter what, you do have to run a tunnel exiting exhaust that enters into the inner loop of the track where there's never a pressure differential regardless of the conditions. So to get away from all bogging on boost, it requires both intake and exhaust modifications, and then you can confidently and completely eliminate bog as function of snow. Bogs, though, we're going to talk about, are the manifestation of 100 other problems not related to any of that. And they may even be worse in deep snow. So we're going to go down that rabbit hole a little bit here. Well, I'm going to just change that so you can see what it does without any restriction at all. Let's change that time to Barrow. Okay. Now, we're going to blow this run up here. We're going to take a data sample right there, and you're going to take a look at that. Let's see, our Barrow was 10.1 when we let off the throttle, right? So it's holding at about a 10.1 right there. When we were on the throttle, the Barrow was 9.72. That's dangerous, isn't it? That's close to that problem. This was a stock intake with no snow across the meadow. And it pulled 3/10, almost 4/10. It's interesting. So what did we learn there? We learned that when we draw enough air through the stock intake to produce 11.6 pounds of boost, it's even more of a problem. So the higher you turn them up, the guys with big power, the more intake you need, right? I mean, that's almost a dumb self-evident comment, but higher boost is more in, air out, demands increase. And so the disparity of the stock intake becomes even more prevalent. Stock, obviously we ended up having to change intake on this. It was enough to run it, but if you'd have got any snow on that, it would have bogged.
And when you're running big boost like that, you are riding this line all the time.
All the time.
It doesn't matter what
Yeah.
you got up there.
So that's just, these are just facts. But like I said, our facts come from actual data, not just BS on Facebook. So careful with the BS on Facebook. I'm putting this out there to the world. We're going to put this out on YouTube, but I really just want you guys to be careful with that. So on that one, yeah, we got there. Okay, so back to our list. We did that one. There was another product that I thought was worth mentioning because there's a lot of comments and conversation about it. It's the valve that goes in the back of this factory charge box, not to be confused with the upper plenum or intake box, okay? Those valves, have we seen them? The factory Polaris has a giant reed back there. So you can remove the reed and you can put in a valve. So does anybody know what that valve is? Has anybody seen it? It's in a billet aluminum thing. TRS is one of the manufacturers. A couple others that do it. And again, I know Tony well, test with them. It's not total snake oil. It's not at all. But it will not have an effect on bog. When you're pinned wide open and you're wide open, okay? We're wide open. And you hit that deep stream bottom pillow fluff and your sled bogs and you never moved your hand off the handlebar. Can anybody imagine a world where that bypass intake valve had any play? That thing's closed. You could have duct tape over it. Doesn't make any difference. It's not a matter of leaking. That's just BS, man. It ain't gonna change your powder bog. What it will do though, is it'll eliminate that reed rattle that you hear, particularly when they get hot. So you will notice that the Polaris does have like a, particularly when they're hot. That's the intake reed valves, the bypass, changing from an ambient intake to overcoming those reeds with boost and closing. And there's a bit of a flutter that the reeds incur. That represents about it was 28 milliseconds is what we were able to quantify after hours and hours of data logging. There's a 28 millisecond advantage to a TRS valve, and it eliminates the audible rattle of the reed. I'm here to tell you with absolute certainty, none of you can tell the difference in response to 28 milliseconds, okay? But you will notice the sound, and it is smoother. I like it.
It is quiet.
But it is expensive.
It's also
it is
$400.
heavy. It's heavy, it's expensive, and it does put some hardware in your airbox close to a very vulnerable point worth mentioning. No, I don't know many of them coming apart, but in the event they did, it would really suck because those parts would go right into your motor and consequently right through your turbo. So,
Which ruins everything.
I'm just saying. I'm not saying it's bad. Tony, don't take that wrong. It's a cool part. Whatever. Okay, so we move past that one. Most common complaint, Boost, the biggest problem on Boost, and this goes for kind of a lot of Polaris snowmobiles, the fuel pump. Get low pressure codes and your sled doesn't run, or your sled bogs.
It's loud.
Or your fuel pump. You open your gas cap while it's running, it sounds like there's an end mill running inside your fuel tank. Has anybody heard of this? This is a big deal. This is a very big deal. So what causes the noise? First of all, let's go into that. If your fuel pump sounds like an end mill running inside your tank, you don't have a bad gear rotor pump. The gear rotor pump by design does not make noise and won't unless you starve it. Right. You're hearing cavitation caused by intake restriction. That means either your hose is pinched or your filters. Yes, here, we'll pass that around. Here's a filter. Pass that around. So everybody kind of knows the story that these things came out brand new from the factory and they were making all kind of noise. They actually weren't. They were making all kind of noise maybe later on in your first day. There was a manufacturer problem, whereas those little filters that were stuck inside the tank had a micron rating much smaller than they were meant to have. The vendor screwed up, it's Walbro, and they contracted with somebody. It wasn't even them that did it. It was the guy they contracted with that built the filters that made them too small. So those little filters do plug up in time though. They are still a filter and a replaceable filter. And when they do plug up, what caused the first ones to plug up, I'm told, I don't know if this is true because I'm not involved in the kind of the refining process, but evidently they put like some weird polymer that soaks up water and in fuel when it's transported, and that polymer, when it would receive any moisture or water, soaks up water, wouldn't fit through the filters, so you couldn't see it, but it plugged them up and immediately. Anyway, that's what I'm told. I don't know if it's true. But either way, I do know one thing. Those plug up. You get a rusty race fuel drum and those things turn black and your sled sounds like an end mill running in the tank. Change those filters and it runs. But prolonged cavitation won't necessarily damage the pump, but it does put excessive strain on the electrical system related to running it, and it can. And there can be other related failures. So we do see with the fuel pump failure that ones that have had maybe repeated problems with plugging or used bad drums. I think we had one example of that,
I
right?
mean, yeah,
you had a bad
even,
drum.
even stuff out of pumps. At the
Yeah,
gas
yeah,
station.
or a
It's-
particularly dirty gas station and constantly running into plugging and constantly running into that it actually stressed. I think we determined on one that the PBR failure was related to the pump being stressed all the time because it's been sucking and changed filters all the time. So problems on downstream. The PBR is like this wildly overcomplicated regulator rectifier that is a known failing component and can cause a fuel pump failure, but typically doesn't. But it's the device in charge of distributing the correct voltages at the correct times to the various components on a snowmobile and on a Polaris snowmobile. It's a large silver thing under the intake behind the ECU. It looks like an ECU, but it's basically a regulator rectifier that's I believe has some voltage shunting circuits, and that's how we see it. So like we look at this all the time, and we can tell with our data log whether or not we have one that's going to be a problem. Let's change that barrow to we want critical voltage first. We got fuel pressure on there, right? Already?
It mirrors it
Yeah, so
anyway.
the top one's fuel pressure. So this would be your critical voltage right here. And this tendency that you see right here where these drop, we have minimum and maximum thresholds that we look for on this, but a bad one will shunt this baby, or it will show a drop in voltage down to 10, 11, 9 volts. That's when we start to be suspect of either the fuel pump or the PBR. This is a nice healthy line right here.
Yeah.
But that's not what they look like when they're failing. But you guys won't know that. You're riding your sled, and all you know is it's just not running that well. And that's literally it. That pump isn't making noise. It's just not running. It's not running, and we look at it, and we'll see that the fuel pressure starts to drop from like 55. We're going to see you with 49 at wide open throttle. The reason it's not running is because it runs into a correction table where it's correcting for a lack of fuel pressure, and it's not only do you not get optimal atomization or optimal spray from the injector at lower pressures, but it's going to overcompensate with more fuel to avoid detonation. So your sled's not going to run very good, but you don't know anything's wrong other than it just doesn't run very good. The only way you'll find that, if you take it to your dealer, they're not going to know. They don't see this data. Is literally to log
Digital
it.
wrench will not tell you this.
Right. This is the kind of information that only guys kind of in our field will be able to help you with. So feel free to reach out if you got a trouble child, but just know that when there's a solution, and it's typically in the data, to every one of these boosts out there that doesn't perform the way it should. And it perceivably is fine. You're not receiving a code yet. This thing can be clear down to 44, 43
I think it's
before
like,
it triggers the, I can look at that in the,
It has to
again,
go
I
pretty
don't
low
want
in
to,
order for
I
it
don't
to
want to bore you
trigger,
guys, but there's a table for when it triggers the low pressure light to come, or low pressure code to come on. I think it's 43, maybe
Yeah.
42, whatever. But it's supposed to be running at, as close to 60 as it can,
Yeah.
right? Never less than
You drop
55
below
or 56.
55,
Yep.
you're
At wide open throttle, like the fuel pull on this one is massive because we have a ton of boost, right? So we're asking a lot of that. So you're going to see a slightly lower. A stock one's typically going to lay in there around 58 or so, 58.6. And we know that's a good healthy pump with a good healthy driver in the PBR that's giving it all the voltage it needs to do its job, and the filters are clear or it wouldn't be there, right? But that's where we analyze this data, look at the voltage, look at the fuel pressures, look at some of the other variables that are involved in that, and we can tell based on, for instance, what the pulse width prescriptions are on the injectors and things like that, and just kind of know what's going on and say, man, that thing shouldn't be that low, or it should be. So
Or a
just-
perfect example, like you've probably seen before, you're like, oh crap, I got a low fuel pressure code. And then I pull this up and I'm like, well, that's weird. You have 65 PSI. Whole nother problem. We'll get into
Right.
that in a minute. But
Right. So we have lots of logs.
We
We
improperly
should
diagnose
could,
something with that code as well.
Correct. That code won't tell you that you actually have a bad fuel pump, plug filters, or a bad PBR, or any of that. A low fuel pressure code can be, well, you're out of gas. That's one of them. But if we log it and you make 10 pulls and they're fine, but then all of a sudden there's one pull where there's this massive spike to 0 and back up within like 5 milliseconds. This guy here dealt with that. He was our first one. You were our first victim. get a call and it's like, hey, my sled I just picked up won't go across the meadow. I can't even make it to the other parking lot. It says low fuel. And it was a sensor, it was a harness problem. So there's a known problem, and it was first manifested in 23, and you'll see it across a broad spectrum of different things. The TPS has some of this as well. The fuel pressure sensor harness, about 3/4 of an inch away from the plug, was very vulnerable to a broken conductor caused apparently during the assembly and the clamping fixture, something that affects stressing the conductor but not breaking the insulation, so you wouldn't know it. But if you pulled on the wire, it was like spaghetti noodle.
That dang little pink wire.
Right. It was most commonly the pink wire on that harness. But there's a harness upgrade available from Polaris. We use a GM part number, and if anybody wants to know what it is, can hit us up. They sell a little pigtail harness that replaces that,
Go
and
right to
eliminates the
Napa.
problem. Yeah, you can get it at Napa. So anyway, those are known issues with Boost. They do have a recall on the harness. They don't give you data logging equipment to determine which component needed changed, right? So just know that these problems do exist, and as they come out and they will manifest similarly, but not necessarily be the same problem. So don't look to the fake book for your answers as to what it is. You get on these forums and somebody's gonna, if I were to post anonymously, low fuel pressure code on my 23 Boost, please help. I'm gonna get 75 keyboard warriors that are gonna tell me everything it isn't. So how do we know? We know because we look at the data. And that's what we do. So feel free to call, reach out. We don't charge anything for helping somebody. We should, but we don't. So we're here for you. Give us a call, we'll try to help you get through it. But there are some things you can do. Our device that we sell does log, and we can view that remotely. And just to put a little shameless plug in here, the VTI device allows you, the user, to log his snowmobile and then send me the log, automatically upload it to my cloud. I will analyze the log, and I will tell you what's wrong with your snowmobile based on that data, and I do charge for that. The device costs money, and I do charge by the hour for diagnostic help, but I've saved many people's seasons by doing that. So just know that that's available if you don't want to go down the frustrating road of chasing some of these little problems that are obvious to us. Most of the time, I can look at one of these logs, it's 10 minutes, and we don't charge somebody. That's the truth. We charge $150 an hour if we spend any real time on it. The device itself you can buy for, it depends on whether you want to use it to tune or not. If you're not tuning and you just want the device for diagnostics, capacity to relearn power valves or relearn your wastegate or do data logging and have us analyze it, I think that's $399 for that device.
I believe so. Yeah.
No, it's not. It's a pretty cheap deal.
And
It'll
we will
read
figure out what's wrong with your snowmobile.
Right. It'll
100%.
read and tell us some detailed information regarding trouble codes. You have access to that. You can clear it. Like if you had a bad pipe sensor and it hard codes the ECU, you can go buy a pipe 10 sensor at your dealer, put it in, and then just clear the trouble code and go riding. You don't even have to come see me. Otherwise, you're going to visit your dealer. They got to put it on digital wrench. They got to go through that process, right? So our tool's a really useful tool. But I'm not out here just trying to sell my tools. I'm trying to save bad days, and that's really it. So. No, you don't need a laptop. You don't need anything. It's a standalone device. You can come by the booth. We'll show you. It's a little device plugs into the.
You can hook it to Wi-Fi right off your phone if you're out in the backcountry and you get service. And
yeah, you can send me a log while you're on the hill.
Look at it right then
through a hotspot. So, we've had many instances where that's been the case. So, guys that are that have used us or guys that know us or are familiar with us know how that system works. But we're literally a phone call away. You can give us a call and say, dude, I just sent you a log. This thing's a disaster. I'm up on the hill. The snow's 40 inches deep, and I want to go ride.
So we can. Weird. Your exhaust temp sensor's 60 degrees.
Right.
You should probably screw that back into your can.
Right.
Or your pipe.
Yeah, it fell out of your
like,
pipe.
oh,
No kidding. Yeah, it's probably laying there in your belly pan. Or maybe next time you should plug your baro sensor back in. Oh, I did have my hood off last night. Son of a bitch. So we can see that right away. We solve a lot of bad days. Your fuel mode switched.
Yeah.
You're up there running on. You put good fuel in it for a change. You're 91 non-eth. But the ECU thinks it's in F mode, so it's giving you the extra 10%, and you're bogging all over the place.
Which they would switch themselves.
They will
23s
switch
were
themselves.
really
Yep.
bad about it.
So you can see here, we can read the fuel type. We can read everything. So, well, anyway, so that's what they're. Okay, so we talked a little bit about PBR failures and how they manifest. Like if you have a flickering headlight in an idle, sometimes that can be a good indicator of a PBR problem. Just know that. It's not always, but it
Not
is
always,
one good. I'm just trying to think of seat of the pants things. Fuel pressure sensor, we're ripping down our top 10 list here. EV wastegate actuator failures. Typically results in an H-bridge code in conjunction with a position check failure. If you get both of those codes, you probably got a bad actuator. That's a good chance of it, right? One or the other, not necessarily. Position check failures that you'll see on your gauge
You'll see
are
that
common.
a lot, especially when your sled's cold.
But if
First
it's-
start up in the morning.
Yep.
You'll see that.
Not a problem. You can ignore that code. So, simple position check failure is not necessarily indicated an actuator problem. When you see an H-bridge code in conjunction with it, it's generally a failed component. So, just worth mentioning and something good to know.
First thing I'd do is take your tuner and relearn your wastegate and your exhaust valve, and then see if that fixes it.
Right, and if it doesn't fix it, why? But if you don't have your VTI, then you're on your own. Okay, so the fifth and a very prevalent problem starting in 22, it's gotten progressively less of a problem over the years, and how it manifests. And this one's like particularly important for everyone out there with a boost that runs, but it doesn't run great, and it used to run a lot better, and it doesn't pull RPMs. Maybe it bogs a little more than it used to, but it doesn't pull RPMs anymore. This is a throttle body adapter leak. The throttle body adapters, there you go, we'll pass that baby around.
Yeah.
This is a rubber boot, flange, intake flange, some people call it, just pass that around. Those are prone to tear. They tear in a number of different ways and for a number of different reasons. 22s failed commonly, 23s slightly less, 24 was another improvement. They're made by Moto Tazaneri, who is a reed manufacturer, and very, they're a quality manufacturer, but I don't think they realized the amount of heat and pressure we were going to put to these things, and they were delaminating. And so the 26 is an all new part, promises never to tear. The 25 rarely tore. 25,
Never saw
few.
a lot in 25,
Yeah.
but they did do a new one in 26.
So, does anybody jump out there, grab you a billet one? So 22, for instance, had a V-band clamp on the airbox. 22, the throttle body was fastened with a V-band fastener like that to the throttle body, and then another one to the airbox. Okay, and that had a rubber fixture on the airbox that was molded to it, which were prone to fail at the juncture on the backside. So opposite of that, the other end of it.
Yeah.
But if you put a billet one on there, you're sure to fail that within about 20
Can anyone tell me
miles.
why it's made of rubber right here?
Not just a seal.
Not just to
no,
seal
you
it.
could seal it with an O-ring. And when you replace that part with a billet one, is you impart that engine vibration directly into a whole lot of other things, including your throttle body, which happens to have your auxiliary injectors and a TPS on it. And it has those two related harnesses. So guess what's going to get the crap vibrated out of it now? Those two harnesses. So if you thought you had a harness problem before with auxiliary injectors, you really got one now. With a 22, you got an airbox problem now too, and they charge like $600 for that airbox. I would recommend though, if you do tear a 22 box, do not replace it with a 22 box. Boondocker makes a adapter kit, changes it to a flange style adapter like the 23 and newer, and then you can buy 23 boxes for like nothing.
Yeah. Call
You
us.
can
I got
call
a
us.
whole pile of them.
We'll send you one. They're a spigot style, they're molded plastic, and they're far more durable than the 22. But with the billet flange, we've actually had the 22 both tear the boot at the clamp and break the spigot off the airbox. I wonder why that is. Could be because that part needed to be somewhat flexible, and that putting a billet aluminum one on there eliminated that flex point and created a lot of problems. That does segue into the next one, which was auxiliary injector failure. So Polaris, did we bring injectors? We were gonna.
I didn't grab any.
Anyway,
no.
Polaris sells their injectors as an assembly with the harness. They have an epoxy-filled connector that connects to the injector, and then that's sold as an assembly. When you have an auxiliary injector voltage error, you have failed the auxiliary injector harness, but you have to end up buying injectors. Everybody says, it's a junk injector. It's not a junk injector.
Never seen a bad injector.
We actually rarely, if ever, see a bad injector. It's because the harness breaks, and it breaks generally at the pinch at the zip tie fastener component that sort of fastens to the front of the airbox.
Yeah.
And that zip tie gets a little loose and it rubs through, and then it breaks the conductor, and then it fails. Those manifest before you see the injector failure. You see det codes. Man, I got a det code, max detonation. So what do we do when we get a max det code, everybody? You shut the machine off and you restart it, you keep riding.
And then whack again.
And then, damn it, I got another det code, but it didn't sound bad, so I just shut it off and
it's just hot
restart
today.
it. Just hot, it's bad.
Yeah.
Maybe I got a little gulp of bad fuel there. So we increase the octane of the fuel, maybe. Go back to your buddy, steal a gallon of avgas, whatever. And your det goes away for the day, but then the next day it comes back, so you put 2 gallons of avgas in that baby. You got a leak or a bad injector, and you're being stupid, and you're effectively tuning a broken snowmobile with something you shouldn't be. Fix the damn problem, okay? No amount of detonation, I just want to go on record as saying this, no amount of detonation is acceptable. 0. Repeated detonation events, though they sound benign, even if they're transitional, will inevitably either break the material between the ring landings out from the piston or break the material below the ring landing above the wrist pin. Period. Hard stop. You're going to break your motor. Don't do it. Stop. So it's critically important that you do not continue to ride a snowmobile that's manifesting det codes. But a common cause, particularly in 23, due to some harness changes, was the auxiliary injector harness, and it's a very, very common problem. And the first thing you're going to get is a det code, and then you're going to get that matched to an auxiliary injector voltage error. That needs new auxiliary injectors. It should typically be a warranty item. No guarantee on that, depends on the dealer, but that is a very prevalent problem. Now, what on a 23 can be done, and even on a 24 can be done to help prevent this if you're not having the problem yet, is to periodically go and refasten or retighten the zip ties, even wrapping it. There's a small white band which indicates the point where the zip tie is supposed to go around that harness. As that loosens up, it slides over away from it. It's no longer pinched there. That rub, chafing, and ultimately stress riser creates the conductor to fall, and that creates the problem. So before that happens, look at your auxiliary injector harness, where it fastens with the zip tie, tighten the zip tie up, add another zip tie. Things like that will help. Not a guarantee, because a lot of the problems were because those harnesses were not epoxy filled where they attached. The 22s were, and in 24 they went back to the epoxy filled, but they still had pinch point problems. 25 represented a mild change in how they pinch it. 26, another change. So you see less and less progressive problems with auxiliary harnesses, but auxiliary harnesses are a problem. TPS harnesses were also a problem in 23 for the same reason the fuel pressure sensor harness was a problem. Something regarding the manufacturing of it and creating a compromised conductor very close to the plug. You can, again, back to that, when you're trying to diagnose a harness, you can physically feel it. If that wire stretches out, like the sound effects, no extra charge. But if you see that stretch out and you let go of it and it comes back, that means the conductor's no longer connected. If it only screws up when it gets hot, that's because the insulation gets soft enough and relaxes that the conductor no longer makes contact. Follow me? Simple stuff, but that's what's going on. Do we have harness problems? 100%. 100%. We have harness problems. We kind of know where most of them are, but it's a problem. Gets better every year, but it's admittedly a problem that plagues the Polaris Boost. So, just making that clear. Okay, so we move past that one. We're almost done, guys. Yeah.
On the harnesses, typically when you replace them, one being bad, are you still having a chance of having another issue, or is it fixed for good?
If you replace a harness with a brand new harness, you're asking?
Yes.
Yeah. Nowadays, yes. Once they updated that part and it's the new epoxy filled harness, you're fine.
Hey, on that torn boot thing, I wanted to say something too. As those throttle body adapters tear and it begins to leak boost, it doesn't achieve the target boost. So the compressor is working its ass off. The turbo is working harder and harder and harder to put more boost out that it's leaking, but to try to hold the boost level up. So it's closing the wastegate more and more and more. As it does that, what is the detriment to that? What is the single thing or the result of that giant intake leak? And yeah, what's the bad thing? What was the word? You said it first, didn't you? You raised your hand. Yeah, you're building heat. So you're a double winner today. So you're going to see up here on this same thing that we're actually mapping our temperatures here on this window right here, and you'll see that we have coolant temp, exhaust temp, boost temp, and MAT. That's manifold absolute temp, and you're going to see that boost temp. You'll be hitting like 6 psi with a leaky one, asking for 7.5, but you'll see 180 degrees in that. That's 6 psi. That 180 degrees is really hard on reads. It's really hard on runnability. It's more prone to detonate. It runs like dog crap. It's not pulling RPMs.
Slow.
Slow
Builds
as
boost slow.
crap, but it's not throwing any codes. You just got smoked by your buddy's Gen 5 though. So it's important to pay attention to how these things manifest, what they look like. That sled is performing, you have known good clutching, and you have known good parts, and it's formerly run great. That's a thing we get all the time, right, Chase?
First question I'm going to ask you if you call me.
Yeah,
Has it ever run good? And when you say yes, I'm going to be like, okay, what changed?
right. So
And if you say no, then I'm going to be like, well, I don't know if that's true.
right, we do get that. We get the guy that high fives us, says this is the best sled I've ever had. It runs amazing, and then 3 months later, this thing's never ran.
Luckily, I save all your data, and I can
You
tell
know who you are. We've got your data. Anyway, so yeah, problems do come. And as they come, it's important to address them. And they're not impossible to find, particularly with a logger. I can't stress enough how important that log data is and how much value it has. So keep that in mind. Okay, so yeah, and that heat is a terrible, terrible thing to impart into the system. And I mentioned that it leads to reed failure. This is for another thing. The most common cause of reed failure is oh, dang, man.
Bingo.
Guys, this guy's Johnny on it. Exclusively, what tears up reeds is detonation. Detonation is happening a lot with pump gas units, particularly stock boosts that run on 91. When you see we're tracking detonation, and you'll notice that that's essentially a zero when there's none. If we were to pull up, say, a stock unit, bone stock, you'll see constantly 2, 3, 4% corrections on factory mapping. It's constantly deading a little bit, and that's the reason why reeds will be compromised and broken. Now, are reeds just something you have to replace on a boost every now and then? Hell no. Nope. I got guys with 3,000-4,000 miles on them, never changed a reed. I got guys that can't make it 500 damn miles without changing reeds. The difference? Detonation. Run on pump gas, detonate. Run on good gas, fail parts, detonate. Detonation breaks reeds. That's what it is. If anybody tells you anything else, they're lying. That's the thing. Yes, you could compromise the reed with heat, but there's no reason that reed should fail for a very long time from material fatigue unless you're detonating it. And that really is the thing. That's like the thing that breaks them.
I can only find one little fella here.
Oh, okay. Yeah, so we could probably show houses and condominiums, we call them, but we get these little things, and that shows a detonation event.
But if it looks like the White House right here,
yeah, and keeps going up,
yeah.
It's very, very bad. So detonation tears up reeds. Just know that. That's what leads to that. Where were we at here? We were almost there. The wastegate sticking. Critical for all boost guys to get to this point. The guys that store their snowmobiles after rides in an enclosed trailer overnight and heat it are the ones that are the worst offenders of this. Not that that's a terrible thing, but that condenses a whole lot of moisture inside the exhaust pipe, and it ultimately rusts these little parts here. Yeah, you get an idea here. Here's one that you need to pass around. That's a wastegate, and you'll see there's a butterfly valve, and the axle on that wastegate is rusted solid, and you can't move it. Right, and this happens only, exclusively, at your first ride of the season. This does not happen middle of the season. Things fine. It's all oily and crappy and everything's good. Even if you left it in your trailer and get it away, it still works. It's when you left it at the end of the year that moisture never had a chance to leave, and it rusts over the course of the summer. And that baby is solid. You can't move that thing. Put a 1/4-inch ratchet on the end of it, work it back and forth for 2 hours with some WD-40. Maybe you get it to work again. Those are hundreds of dollars.
They're $800.
Yeah, I didn't know that, but they're too much.
Yeah.
So how you prevent that's really simple. Periodically squirt a little WD-40, which is a water dispersant, hence the WD part of WD-40. Well, the water dispersant factor on that will go down, penetrate the axle shaft on that butterfly, and ultimately keep it from rusting. So if you get on your boost on the first day,
Soak
you
the heck
go
out
to
of 'em.
take off up the hill or across the meadow, and you're like, this thing ain't like boosting. That's the call we get, right?
Yeah.
My sled's not boosting.
I didn't hear the what you
There's no what you.
Yeah.
It's slow. It's that. It's stuck. It's your first ride of the year. Sometimes you can get away with it. Go back to the trailer. You know, be careful to exercise it. Don't just put a pair of vice grips on the one end of it because it breaks the spring
Yeah, I
tab
broke a few.
off the axle shaft. If you do that, remove the drive cable, which is a 1/4 inch, from that end of it. Remove the drive cable. You can just loosen the actuator motor. You should relearn it after you do this process, no matter what. But remove the drive cable, and you can put a 1/4 inch ratchet or a breaker, 1/4 inch breaker type bar, whatever, you know, little 1/4 inch T-handle. And you can work it back and forth with some WD-40, keep spraying it, or with any other type of penetrating lube, and just get that thing to work again. Some of them are savable. I'd say 80% of them are savable if they're not too bad. But those wastegates are expensive. It's preventable. It's not exclusive to this tune or this fuel or that fuel, though the weld tune units are drier in the pipe environment, probably have less oil there. So the weld tune units are probably more likely to have problems with this than the ones that are just slobbering oil everywhere all the time. Just a personal observation, but it's a prevalent issue on boosts. So if the thing doesn't run right out of the gate, or you just bought it over the summer and you go to ride it and it doesn't boost, don't go shoot the guy you bought it from. Just try to get the wastegate working again, and should do a relearn. Okay, throttle cable, throttle safety override switch failures, and not to be confused with TPS failures. TSS and TPS are not the same. Throttle safety switch is found in all 24, 23, and 22 boosts, and not in 25 or 26. The 25 and 26 got a new cable with a non-stick kind of PTFE coating over the cable, and they eliminated the TSS, or throttle safety switch. They employ a resistor down in the harness, not unlike what the aftermarket's been offering for years. That resistor just eliminates the TSS. That does mean something, though. If you throttle sticks, it's stuck. It's going places. So don't let your throttle stick. Pull your tether. Always wear your tether. Very important. So
another thing about that. So just to solve it once and for all, because I keep reading it on Facebook and I need to even quit following these pages, but you can put the new throttle cable in the old throttle.
Oh yeah, I got that written down here.
You do not have to replace your throttle
100%. You have to put the throttle assembly, the throttle cable, and the throttle paddle from a 25. Does retro to a 24 or prior. And it will eliminate this problem completely. And one of the cool factors or cool things that happens is you no longer have the floating pin at the axle point of the throttle lever. So that's where the problem exists in deep snow and cold snow and bogs. We get bog. I sled bogged today. It sucked. It's cold and deep. It sucks. And a lot of the time on 23 or 22, 23, and 24, it's due to ice and snow getting in the void or the gap that is supposed to allow the pin on the axle of the throttle lever to float and activate the TSS. And when the TSS doesn't activate, it begins to bog when you hit the throttle.
Ooh, this would be a good time for this question. This is for a hat or something. How many times will your ECU log a code before it
This is a good one.
Yeah. What's the maximum amount of
Does
codes that
anybody
the
know the
ECU will
maximum
log on a
number of
certain-
loggable stored events on an ECU? Wrong.
Wrong.
All right, just for the next one, it's 126.
I was gonna say in the hundreds, because I thought I
Yeah.
one time.
So you'll get 126 events.
So basically, what,
And that
to
just
what you
means
were
it did
saying-
it for a million. It just did it a million times.
To what you were saying, my sled bogged all day when it was cold. Well, I just looked at your codes. You have 126 maxed out throttle safety codes.
Right.
That's it.
So the answer to that is maybe your TSS needs replaced. Unlikely. Maybe it needs disassembled, cleaned, dried out, blown out, and lubricated and put back in, and then it's fine. Or just put the 25 and newer cable and throttle assembly and lever on. You do have to buy the resistor. Every dealer sells that stuff. If they don't know they can do this, they should know. But you can go to your dealer, order a 25 cable, 25 resistor, 25 throttle block, and 25 thumb throttle, and put it on your 23 and 24, and it'll work great. Okay, so and the last one was a big one. This was for a pretty good prize. So we were talking about lockout shocks in one of my little blips online, and the difference. You are disqualified.
What? Okay, you're up. He pointed to me.
All right, you're disqualified. Hold on a second. I want a very specific explanation to test the knowledge base in this room. We're talking about new lockout shocks, why they're an effective tool, and the former star of the show was called an ARC, and the ARC was a device that was cockpit controlled just like a lockout shock, but it had a functionally different fundamental purpose. Can anybody tell me what that purpose is? I think he actually raised his hand first.
This is a guess at the arc was basically to be more like a brake to bring it down when it's rising up.
True.
The lockout basically keeps the sled from rising.
This is it.
So as you're climbing steeper terrain, you basically use your lockout in the rear as far as like on a box airs to keep your front end down.
Okay, I'm sorry.
No?
That's not going to meet it. We'll talk about why. I mean, they actually both will hold the front end down. All right, so who was the second guy to raise their hand here? One of you two. All right, go ahead. Tell me what it is.
The shock locks.
Does
And?
what?
What does it do? Wait, you can't add to it. He's talking.
Hold on. How am I disqualified?
I agree.
The arc locks out the scissor from actually moving.
Okay,
It does not allow the suspension to move by locking it to the rear post.
but it doesn't stop the suspension from moving. So you failed. It still moves, but what does it do? These two already know. I'm going to have to take care of both of you on this because you already know. All right, so I was fishing for the term coupling. And what people don't understand is the rear shock lockout only stops the rear compression event from taking place with as much ease as it otherwise would have. It doesn't actually lock the rear scissor solid, and it doesn't, but to your point, the arc stopped the lower portion of the rear scissor from moving backwards, which couples the suspension, forcing front arm involvement. That's the coupling effect.
And the whole thing moved.
The whole skid has to move now. So it doesn't, so the difference is a rear lockout shock will stop a rear arm compression event, but not affect front arm compression events. But a coupled skid forces it to not be allowed to have a rear arm only compression event. But when it does push the rear arm up and overcomes that resistance, it's bringing the front arm with it. So that's called coupling. And the factories have always used coupling blocks to install on skids, on trail machines, to what? Keep the front end down. A coupled front or rear skid is going to be more effective than just a lockout. Period. Hard stop. I love the E shocks and I think they're great, but they will not do what a coupled rear suspension does, forcing front arm involvement and holding the front arm down. Yes, it plays a role. It is effective, but not as effective as a properly tuned and installed arc. I wish they still made them. They don't. It's just my personal little rant there. But yeah, we're going to have to take care of both of you. I only brought one of those big prizes. You'll have to come to the booth and get it. Maybe you two arm wrestle. I figured you guys knew the coupling, but it was coupling, and that's the difference. One of them makes the rear really stiff. The other one actually couples the rear skid. coupling the rear skid is a highly effective tool in trying to keep it down. The ARC is a really cool tool. It's just misunderstood and ahead of its time, and I wish it was still built. But the E-shocks are very cool. So if you want to see examples of those products, they're in our booth installed on one of our snowmobiles there. We have one with an ARC and one with QS3s. So anyway, thank you guys for tuning in. I know that was long and arduous, and hopefully we got through all the main stuff, but we're done. Thank you, and we'll post this on YouTube as soon as Aiden back there, the videographer, gets a chance to get her edited up and get her put on. So